Thanks for the introduction. So, tēnā koutou, ko Ben Taylor tako ingoa, no ingarangia o ko tipona, he Pakeha au, I whānau mai, au ki taupo, I pakeke mai au ki taupo ke intonihia, ke au tautahi, au e noho ana. Tēnā koutou katoa. So, kia ora everybody, I'm Ben, I'm the eResearch manager at AgResearch, and I'm here to talk about Flexim for 3 years, which is just an update on our project that we embarked on with NeSI about 3.5 years ago now, I think, with Flexi HPC, and just kind of how it's gone, recap, etc. So here's a quick agenda about what it's about, an overview of what we're doing, the benefits of doing this work together, our journey so far, the wins, the challenges, the lessons. It's in a nutshell. So I'll get straight into it. A wee bit of context from way back in actually 2019 was we had a traditional in-house HPC cluster. It was getting old. We had constant demands from various researchers and stakeholders in the business around wanting GPU, wanting more data, wanting more compute, you know the story, and data's coming left, right and centre, and things such as wanting Windows workloads and all those various kind of requirements. And so we embarked on a project to refresh our infrastructure, to get new compute and storage, to deliver a fit-for-purpose eResearch infrastructure that'll meet our plans and our requirements. So we wanted to de-risk our current environment with a new platform and provide a central infrastructure platform for all of our diverse needs. Traditionally, it was largely genomics that we're servicing, but we wanted to meet this for everybody. Here's our previous state. I like this diagram because it's awful, but it roughly shows you just the complexity of what we had. We had 4 data centres across New Zealand with infrastructure in various locations. The key thing to take away from this is we had data stored in the cloud, we had data stored in our VMware cluster environment, we had data stored in our HPC. It was literally, if we can find a place to put data, we'll throw it in there. So yes, data everywhere. So we initially went out on a procurement for an RFP just to replace what we had with something similar. And we released that in about September 2019. I just went through these dates and went, wow, it's been a long journey. And through that process, we were looking at just replacing it internally, and we went with the preferred vendor of Datacom, which is an HP-based solution. And as we're going through a detailed design exercise, that's about the time that this Te Pai Kahurangi report came out, which really started signalling the changes in the sector, which, as you've heard, are now being realised. And so it was through that we decided to kind of pivot and work with NeSI and discovered Flexi HPC and the ambitions that were happening there and that we wanted to align. Now, before I delve into that, I just thought I'd just quickly outline what the solution we're looking at was in that RFP. So it was a commodity compute cluster, so we had your traditional HPC computing environment. We had a virtualization environment for these other bespoke kind of Windows workloads, interactive workloads that we needed. And we had what I called a mullet storage system. So it was short in the front, 1 petabyte storage with a large back end, 3 petabytes. So that's what we really liked. HP have a product called DMF, or the Data Management Framework, which is an information lifecycle management, HSM, hierarchical storage management. I nailed all those. System, and that just allowed us to kind of have fast tier and just keep growing the back end as data keeps coming in. That was the plan, data management and actually trying to understand data. Problem for another day. So that's what we initially were looking at, and here's my rough job at trying to make that a lot more high level. So here we are, 2 sites, object store each site, the big file system here, cluster, virtualization computer, woohoo, that'll do it. So anyway, we had this decision point following the report, and work with NeSI was we could carry on with what we've got. That seems like the easy route. No, just keep doing what we're doing, head in the sand, problem for another day. But what NeSI were doing with Flexi and having a multi-tenanted service, a research cloud, if you will, it really aligned with what we were trying to do, and the timing seemed right. And so we recognised that working together we could get scale for both organisations by putting more into Flexi. NeSI can get more, we can get more, and it really seemed to make sense. And so we thought, yep, let's do it, let's partner, let's do this together. So in July 2021, we signed a memorandum of understanding, which basically was the intent to say we want to do this together, so let's get cracking. Look, and we knew this wouldn't be easy. It was a case of NeSI building their services, we're trying to adopt it, or laying the tracks of the train as you're driving it. I mean, there's a whole lot of analogies you can use here. And so before I go on, I just want to acknowledge that it takes a village to build these kind of environments. Here is just a smorgasbord of some of the people that we've worked with over the time and some of the players. I mean, it's a lot of people. I had a slide with people's heads on it. It just started getting unmanageable because it just kept growing and growing. So this is my acknowledgement to all the hard-working people. Some of you are here today. So, with the Flexi HPC taken service, conceptually this was our, again, revised very high-level architecture. So you can see it kind of looks similar. But we still have the same storage system we liked. We just changed out some of the backends. That's what's great with this DMF product. You can actually have a number of different diverse backends to diversify your storage. And the Flexi HPC service would provide the compute cluster, the virtualization environment, and the object storage. So it was like, hey, it meets 3 of our requirements within the service. Great, this is awesome. Now, it's known internally as the ERI. We missed a trick on naming, I think, with the speed we're going at. So internally, everyone will call it the eResearch infrastructure, or ERI for short. So that name's stuck. So very briefly, this is the storage backends that was the reason we went with this HPE solution, what we like with the data management framework product. So we can have these 3 diverse technologies. We have HPE 0-watt storage, which is just really fast access to access files that have been offlined and rehydrated. We have some Apollos here for our object storage tier. And we have SpectraLogic tape library to deal with, I guess, the deep and cheap scale of storage. So these 3 technologies help give us that true 3-2-1 kind of data protection, if you will, for all of our files. All right, so briefly, just thought I'd highlight the benefits of doing this all together. So the obvious one was scale. By working together with the procurement, we could really add scale to both the Flexi HPC service to benefit both NeSI as well as ourselves. It allowed us to procure more storage for a similar capital investment. And most importantly, and I love this, is we had access to NeSI's expertise in this infrastructure. So I went from having 1 internal person to a team of 40 that I could harangue and just kind of get them to tell me what to do. The other one was interoperability. So by doing this together, it meant that we're working in similar operating environments, whether our researchers are working on our own infrastructure in the ERI, or if they're wanting to work on the national platform. So it just enabled this ability to, if you're moving workloads between the 2 platforms or moving data to operating, you're familiar with how it works, and the people that are supporting you know what it is. And so it's been a journey, but that's a really key benefit from my perspective. We also had a federated identity system, so that allowed our researchers to use their credentials and NeSI as well in both environments. So again, another nice interoperability one there. And of course, just to hit it again, support. So now our researchers, they get access to this team of research support engineers from NeSI, who they've got they know very well now. I know Matt Bixley, for example, of the team, have grown to love him. And I can't emphasise, that really is the key piece of NeSI, the secret sauce, is having that expertise. And again, and as part of that, we can keep upskilling our users and what have you. All right, so I thought I'll just do a quick refresh now on our journey and where we're at with this whole thing. So I've just recently been back from Mount Aspiring, so I was like, I'll do a mountain. There we go. And that seems appropriate because it's quite a mountain we're climbing here. So July 2021, we signed the MOU with NeSI and we decided to get started. So here we go. First off the back, COVID lockdown. Okay, that slows us down a bit. That's okay. It made it a bit trickier trying to sign contracts when you can't see people in person, but we got it away. So by September 2021, we put the PO and we got the infrastructure purchased. Hooray, off we go. Then what happened? Oh, there's a global supply chain disruption, of course. So it took a long time to reach things. And it was around February 2022 when we had the first piece of tin arrive, infrastructure arrived at the Tamaki data centre. Hooray. off we go. Yep, global supply chain, still disrupting us. So by August 2022, that's when we had all of the infrastructure. Well, I say all of it, I think one switch took about a year to arrive. There was still not all of it, but enough of it to say, we're good, let's get started. So then it was on to the build phase, and by March 2023, HB had finished building and handed over the environment for the storage so that we could actually start to use it. And so in March 2023, we said, great, we can now start migrating data and we can start building applications and we can start shoving stuff over. And in October 2024, we're about 90% of the way there. It's a long journey. And I'd love to say, hey, we're done, but no, we think we'll be done in March. It's currently the estimate. The last 10% is proving challenging, and that's largely due to the way we're operating. I can get into some of those challenges later. But hopefully soon we can decommission all the legacy things and realise some savings. So I thought I'd just do a few numbers. I just did a stock take of how long it's been, 3 years. What does that mean? It means we've had 83 sprint sessions. We have 1,050 JIRA tasks assigned to this project that we're dutifully working through. We've had 36 meetings with our scientific stakeholders. They are representative across AgResearch and different domains of science, where we provide feedback of how we're going and trying to get feedback of what the experience is like. We've migrated 3,426 data sets, or 1.5 petabytes of data, and we're now growing at 3 terabytes of data per day is our rough numbers we're finding. So we're now, even though we've migrated that, we're sitting at 2.5 petabytes and growing. So it's been a lot. And 10,000 coffees, at least, yeah. Got to get fueled somehow. And of course, these numbers just keep climbing. So I'll talk about some of the wins first of as we've gone. So first up, this is a win. We have a centralised storage system, and that's been huge. Previously, it was just scattered everywhere. Like I said, we find a drawer, we have our drawer to put it in. So this just means all of our data is in one place. That came with its own downsides, because people go, why is all this data? I've never seen it before. It's like, well, it was just stored over there. And that just means that it's a bit more cost effective as we grow. We're being intentional with where our investment goes. This one I like to talk about. Early on in it, as you know, we had supply chain disruptions, but we still had demand from users. This is a specific ugly Windows desktop application we needed to support called Peaks Online. It required, at the time, this great big Windows machine. Steve Myers, sitting right there, he loves this thing, that would be processing data for our proteomics team. However, we had no infrastructure at the time. It was still on a boat, and they really needed this. So NeSI kindly said, well, we can give you through the service a VM to use until yours is ready. And so that was great. So we were able to stand this up and get it running while our infrastructure was on a boat. And that's just, again, underscoring what was really awesome. And this just keeps getting bigger. So an update is we need more power, and we're deploying at the moment 2 more nodes with GPUs and more cores to just keep scaling this thing up. And again, this is great with the Flexi model. It's a clustered model, but it doesn't fit a Slurm environment. It's bespoke, but through this partnership, we can figure these things out. Machine learning use case. So in this environment, we've got a couple of NVIDIA A100s, and this is just a cool little animation. One of our data scientists, Sam Hitchman, of running a PyTorch DeepLab version 3 semantic segmentation framework. Don't ask me what that is. But it produces a really cool picture. But that's processing CT scans to get this kind of 3D representation of a rumen, I think it is. So that's great, and he loved it. He went from using his laptop or a desktop computer to one of these, and it just exponentially improved his models. And the other wins, again, is just another plug, NeSI's research support team. Just having that expertise, different domains on tap for our researchers. If they've got a problem with GIS, they've got a question around genomics, or whatever it is, there's generally someone there to help. And again, they can help on both the NeSI national platform and our ERI, so that's really huge. Right, some of the challenges. Well, the first one would be, I think, is operating pressures. We're building this new thing, but business doesn't stop. At the time of procurement, our environment was 7 years old, so it was this burning platform of it's doing a great job, but we're paying maintenance and it's not big enough, it's not powerful enough. I lost a person through this, my previous Linux engineer, Dan Sun, he went to the company during this time, so it just meant we've lost a key resource that had expertise. We had increasing cloud costs that we needed to balance the books on. Microsoft gave us a doozy and decided to discontinue a product we're using called Store Simple, which just meant we had to find a new home for 250 terabytes before this environment was ready. So it was just all these pressures we're just constantly battling with. And as I said, researchers' appetite continually growing for greater power while we're building. The data growth does not stop, and of course, our resources are constrained. There's a lot of work to do, but there's a finite pool of people, and trying to prioritise what gets done first. And the minute you try and go too wide, nothing gets done. It's a real challenge there. Changing our architecture. So our previous HPC in Invermay was based in Dunedin, 2 minutes. I better run through it. It grew organically, and now we're moving to, so we had to unpick and reverse engineer a lot of the workflows to move it. We had to centralise all of our data sets, and that required coordination and communication with a lot of people throughout. It was not a forklift migration. Appetite for change. Again, scientists had to learn new skills. We're moving from a local environment to a remote compute environment, from interactive computing to batch-based computing, so it really required new skill sets. And we had to kind of encourage logging tickets to manage the work as opposed to just walking up to our previous one person. Multiple parties, things can go wrong. These things are complex, so that can prove challenging when you're trying to go, where's the issue wrong? I think it's here, I think it's here, I think it's here. So it's just acknowledging things can go wrong, and it's important not to make assumptions and try and get that data. Getting meaningful feedback. We would get feedback through escalations at times. Sometimes people are too nice and wouldn't raise an issue with us or feel like they could speak up. Right, lessons. What do we learn? Bring people together. I think that's so important. It's really easy to fall back into your silos when you're dispersed. The minute you bring people together, you can physically feel tension drop and just camaraderie come up. It's really important. Yes, teams, working from home, all of that, it doesn't beat meeting face-to-face and just reconnecting as a human. And focusing on that common purpose. These were huge. Whenever we came together, it was great. These sessions, these conferences, awesome opportunity for that. Cannot stress that enough. Complexity brings complexity. This is a complicated environment with so many parts, so it just means troubleshooting can be difficult when you're trying to narrow down what it is going wrong. It's important to try and capture some data and baselines so you actually have evidence to say, hey, I think it's here and here's why. And just to be curious, try and pitch in to help. Maintain good communication channels. We've used Slack. That's awesome at times to try and get the communication across parties. Focus sprints. Resist that temptation to spread yourself thin. I'm real guilty of this. There's so much to do, so let's put something in the sprint for this and this and this and this, and then all of a sudden we're doing 10 things and we do none of them. So keep them narrow and focused. Don't forget the customer. Think about those meetings you're having and ask yourself frequently, are these the right forums? Do we need to change them up? A huge thing we did is we changed from big room to like a real small weekly meeting with influencers in the community, like 3 or 4 people that would give us the feedback and interact with us. And importantly, celebrate the wins. It can be important when you're so busy with your head down, dealing with issues or what have you, just remember you actually are making a difference, you are making an impact. Will I do it all again? Oh, it'd be exhausting, but I do believe in what we're doing, so yeah, I think I would. That's me. Whew.